When we identify extrema, what we're looking at are anywhere we have a maximum or minimum occurring on our graph, a peak or a valley. When we talk about concavity, what we're talking about is how the function curves from one point to another. And if we just glance at the same graph that we had before, we can see that in some portions of this graph, our curve follows a cup or a bowl shape. And in another section, or a graph could in other sections, follow an upside down cup or upside down bowl shape. So the direction of that curve, the way the curve opens, either up, like we see at the first interval and the third interval, or down, as we see in that second interval, means that we have different values for concavity. To understand concavity, we look at the second derivative of a function. We can see that at x equals -1, our concavity is positive because that curve is opening upwards. So we call that concave up. At x equals 4, again, our curve is concave up. And at x equals 2, our curve is concave down. Just like we saw with a function changing from increasing to decreasing previously, in order to change from positive to negative, somewhere there has to be a point where we hit a 0. And we're going to refer to points on the second derivative where our function value is 0, meaning that concavity changes from positive to negative. We're going to refer to those as inflection points. So anywhere the second derivative is equal to 0, and the sign of the second derivative changes between positive and negative, or from negative to positive, then we have an inflection point, and on those intervals in between, our function is either concave up, meaning it's opening up, or concave down, meaning it's opening down. We can use this idea to help us identify extrema of a function, because if we can identify where a function is concave up, concave down, that's going to help us identify if we have a maximum or a minimum.